Hello friends, this video on work and energy part 2 is brought to you by examfear.com. No more fear from exam. So with this we will conclude our discussion on work. So now we will start our discussion on energy. So what is energy? Energy is nothing but the capacity to do work. Capacity of doing work is known as energy. So as I told you before also, what we think is when we have lot of energy, we can do lot of work. Now as soon as we keep doing work, we tend to lose energy. So that means an object which does work loses energy. That is absolutely correct. An object on which the work is done gains energy. So let us take the example. Let us take the simple example of the same ball. In this case, who is doing work? This hand is doing work. So hand, why is hand able to do work? Because hand has energy. So let us suppose you have eaten lots of fruits, you have taken a glass of milk, so you have got a lot of strength, so you have a lot of energy. So since you have energy, so you are able to do work. So you are pushing that ball, so that means this hand is doing work. So hand is gradually losing energy. What happens to the ball? The ball was initially at rest. Now the object did some work on the ball, so the ball gained some energy, right? Due to this gain of energy, by gaining this energy, the ball started moving from one point to another, right? So that is the concept of energy. Any object which has energy is capable of doing work, but the object which does work will lose energy. The object on which the work is done will gain energy. So in this case, hand is doing work, so hand is losing energy. Ball is the object on which work is done, so ball is gaining energy, and by gaining this energy it starts to move. The SI unit which is used to measure energy is also joule, because energy and work are closely related. I mean, work is not possible without energy. If an object doesn't have energy, that object cannot do work. If an object does not do work, in that case that energy cannot be gained or lost. Right? So work and energy are very closely related. So the unit which is used to measure work is the same as the unit which is used to measure energy. So SI unit of energy is also joule. Now let us look at the different forms of energy which we see around us. There are many different forms of energy. I have named some of them here. For example, we have kinetic energy, potential energy, heat energy, chemical energy, light energy, electrical energy, sound energy. There are so many different forms of energy. But in this lesson, we will only talk about the two forms of energy, that is the kinetic energy and the potential energy. This kinetic energy and potential energy are sometimes together known as mechanical energy. Right? So in this lesson, we are going to talk about kinetic energy and potential energy one by one. So now let us see what is kinetic energy. Energy by virtue of motion of a body. The word kinetic, what does it mean? Something which is moving, right? So the energy which is possessed by a body by virtue of its motion. So whenever an object is in motion, we say that the object has kinetic energy. So for example, let us look at the most common example. Let's suppose when we walk, we are actually moving, our position is changing with time. So whenever anything is in motion, we say that we have kinetic energy. So this is a scalar quantity, because for this we really don't need a direction to specify it. So only the magnitude is enough. The SI unit for kinetic energy is again joule, because it is again a form of energy, right? And for energy we use the SI unit as joule. How do we mathematically express kinetic energy? That means, how do I calculate kinetic energy of an object? Let us suppose if I have an object of some mass m, and that object is moving with some velocity v. So how do I know how much is its kinetic energy? So kinetic energy is denoted by E with a subscript k. So this k subscript stands for kinetic. right? So EK, that is kinetic energy, is equal to half mv square, where m is the mass of the body which is moving with a velocity v. So whenever you have an object of mass m which is moving with velocity v, that body has kinetic energy, and the kinetic energy in that body is given by half mv square. Let us look at some of the examples of kinetic energy. Let us look at this moving car. Now, the faster an object moves, the more work it does. For example, this car. Let us take the example of this car. Let us suppose if the car is dragging very slowly. So what do we say? We say that the car is doing very less work because it is taking a lot of time to reach from one point to another point. But if the car is moving really fast, then we say that it is doing a lot of work. It is reaching the destination from the source in a very short period of time, right? Again, when we think of kinetic energy, you can think of the bullet which is fired from the gun. The bullet is moving very fast and therefore it has a lot of kinetic energy. Or you can think of the blades of your moving fan. The blades are also moving real fast, so they also have kinetic energy. Now, such objects which has got their own kinetic energies, these kinetic energies can also be utilized for several useful purposes. So we will look into that in one of the later slides. So for now, let us try to focus on the derivation of the expression for kinetic energy. Just now I told that the kinetic energy of any body of mass m which is moving with velocity v is given by half mv square. So how do we derive, how do we know that this is the expression for kinetic energy? So let us try to derive it. Let us suppose we have an object. Let us consider that object as a ball right now. So we have this ball which has mass m, which was initially moving with velocity u. Now it starts moving with velocity v when a force F was applied. That means initially that ball was moving with some velocity u. Now I apply some force, so its velocity increases and the velocity now becomes v. So that is my scenario. So let me try to calculate the work done in this scenario. So this is my scenario. Initially it was moving with some velocity u. On application of force it started moving with velocity v. So how much is the work done on this ball? So work done is given by force multiplied by displacement. Now this work done actually causes a change in velocity from u to v. So this work done actually causes a change in velocity from u to v. Now since the velocity is changing with time, that means there is an acceleration involved. So let us assume that the acceleration involved due to this change in velocity is a. Right? Now let us make use of the third equation of motion. So what was the third equation of motion? It was v square is equal to u square plus 2as. So from this we can say S is equal to v square minus u square divided by 2a. Now again from Newton's second law, we already know that force acting on an object is given by the product of mass and acceleration. So now putting this value for S and this value for F in this expression for work done, what do we get? We get work done is equal to mass into acceleration multiplied by v square minus u square divided by 2a. So this a and a will get cancelled. So we get half m v square minus u square. Now if we assume that the object or the ball was initially at rest. So if we assume that initially the ball was at rest, in that case the initial velocity will be equal to 0. So my work done will be equal to half mv square. Right? So that means this much amount of work which was done on a stationary object made the object move. That means when the object was at rest, its kinetic energy was also 0. Now when the object started moving, it has some kinetic energy. So what is that kinetic energy? That is nothing but the work done. Understand it in this way. Let us suppose this was my ball which was at rest. Rest means kinetic energy is 0. Now let us suppose I am doing some work W on the ball. Some work W is done on the ball. And after that, the ball starts moving, right? So now that means how much work is done on the ball total? W. Because of this work done, the ball is gaining energy. So how much energy will it gain? W, right? So when it starts moving, how much energy it has? Kinetic energy, right? So its kinetic energy is nothing but because of the work which was done on the object. I explained you before also, right? Energy contained in a body is used to do work. And when work is done on an object, that energy is utilized by the object for its motion. Right, so in this case, we can say that the work done causes the change in kinetic energy of the object. Work done on the object causes change in kinetic energy, because initially the kinetic energy was 0, now the kinetic energy is non-zero. So this change is brought about by this work done. So we can say that kinetic energy is equal to half mv square. So you understood the logic? Okay. Now let us look at some of the applications of kinetic energy in real life. The first example would be the hydroelectricity generation in dams. You would have seen there are certain places in India also where we have constructed dams. What are dams? Dams are large reservoirs of water which are used to store huge amount of water. Now this water which are stored, the water is generally stored at some height from the ground level. So like this is the picture of a dam. So you have your water stored in these places. So when the water falls down from a height, the water, since it is flowing with a high speed, so it has got a lot of kinetic energy. So the kinetic energy of the water is actually used to rotate the turbine of the generator. I mean, what is the purpose of these dams? They utilize the kinetic energy of water to produce electricity. So how do they produce electricity? They have a generator. There is an electric generator which is used to produce electricity. So in that electric generator, you have a turbine. Turbine looks somewhat like this. So when the water falls with high speed on this turbine, it rotates the turbine like this. The water keeps falling and the turbine keeps rotating. So because of the kinetic energy of the water, the rotation of the turbine is possible, and because of the rotation of the turbine, electricity is generated. Right? So what happens in hydroelectric dam? Kinetic energy of water, what does it do? It rotates the turbine and electricity is generated. Right? Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.